Hi, thank you so much for joining me on this video. In this video, we are going to discuss about JRE. Right now on the slide, you can see that we have a compiler diagram, and this is what we discussed more in detail in our earlier video. But in this video, we are going to discuss about JRE. It's one of the important component in the Java environment. So what this JRE is going to do, we'll have the detailed understanding of that by looking at a diagrammatic flow first. So let's straight away get into the JRE part. If you look at here, I've just popped in with one .class file. So right now we knew what .class file is, right? It's a bytecode that's been generated out of the compilation process. Once the compilation is done, we get a file called .class. And I guess in the last video, we opened the .class file and we saw that it contains the code like a junk, which a normal human can't understand. That's fine because we, as a developer, we code in Java language, and that's highly human readable. And from there, we get another formatted file called .class. This .class need to be handed over to the Java Runtime Environment, that is JRE. It's a place where your bytecode gets executed. So we need a specific platform to run the bytecode, right? And that's what JRE is all about. As the name suggests, Java Runtime Environment, right? It's a place where your bytecode can get executed. It's an environment to run your bytecode, right? So now what I'm going to do is I'm bringing up a Java runtime environment that's simulated in this way, that we have a Java runtime environment right now, and I'm going to hand over this .class or push this .class into this Java runtime environment. Now when I push it, what's going to happen is a class loader is going to come into the picture of the JRE. Now what this class loader will do is, this class loader is one of the important subcomponent inside the JRE, which would help you to load your .class. Now what this .class is going to do with the class loader is, it's going to help you out in loading the .class from a different source. So it could be from the local machine, or it could be from the network, a remote network. So it could be the .class file could be there placed in anywhere, but still this the class loader can help you to load the .class file first into the Java runtime environment. And once after the class loader loads the .class into the Java runtime environment, this class loader will hand over the .class code to another person called Bytecode Verifier. Now what this Bytecode Verifier is going to do is, it's going to verify your bytecode, whether the bytecode meets the standard. In between the .class file got changed, so you open the .class file, you modify that, and then you hand it over, then obviously the file becomes corrupted. And that can be identified with the help of a Bytecode Verifier. When it is verifying the bytecode, it knows that how the version is maintained, right? So if anyone, a human, voluntarily opens the .class and does some modifications there, you save the file, and that is no more a .class. And obviously your JRE will alert us saying that, hey, listen, this is a modified .class. So obviously this is not the original version that was generated out of the compilation. So someone have modified it. So it's very safer that your .class can never be interpreted by someone before it goes into the Java runtime environment. If someone is trying to interpret that code, then obviously your JRE can identify that, and that can happen in the process called Bytecode Verifier. So we have a class loader, we have a Bytecode Verifier who is going to verify the standard of your bytecode that's present inside the .class. And further, what's going to happen is, we are going to bring in the environment called JVM, the Java Virtual Machine, which I'm going to talk more in detail in the next video. Now this Bytecode Verifier is going to push this bytecode into the operating system. So meaning is, you have an operating system called Windows, right? So you have a JVM, Java Virtual Machine, which is very specific to that operating system called Windows JVM. The same way you'll be having for different operating system. But right now, this dot class cannot go into the operating system directly. After the bytecode verification happens, your dot class will not go straight into the operating system. Before it goes into it, it needs to get interpreted. The bytecode can be interpreted only by the person called JVM, but not by the human, right? So once the dot class is verified, it has to be handed over to the person called JVM, and the JVM will take the dot class further. It will interpret to the machine understandable format, which is like zeros and ones. And that detailed video we'll discuss in the next video section. But right now, you can get an understanding that JRE is helping us to load the dot class, hand over the loaded dot class to the bytecode verifier, who is going to verify the originality of the bytecode and the standards being maintained in the bytecode. Once it is done, it's going to be handed over to the JVM, a Windows JVM. The same way, we'll be having another environment, okay, a Java Runtime Environment. For example, if I'm going to hand over this person.class bytecode to this JRE, which is again going to involve with the similar steps that we have seen earlier, that is class loader, who is going to load the dot class, and then it's going to hand it over to the bytecode verifier, and the bytecode verifier is going to hand over that dot class post following the standards. And right now what you can see here is the JVM for Linux. So meaning is, we have a JRE for Windows, we have a JRE for Linux separately, right? So once you push the dot class to the JRE, JRE is going to perform the steps, and those steps are going to be in the format of class load and then bytecode verifier, and then hand it over to the JVM. So right now it's going to be Linux based JVM, and so that JVM knows how to interpret the bytecode to that particular operating system. So this is what is the overall understanding of a JRE. So JRE is nothing but Java Runtime Environment, where you have a class loader operation and you have a bytecode verifier operation. Once it is successful on the bytecode verification, it will hand over the bytecode to the JVM, which is there inside the JRE. The noticeable point here is it's inside the JRE, right? And this JVM knows how to interpret the given bytecode to the corresponding operating system. That's Windows. If it's a Windows JVM, the JVM knows how to interpret for that particular operating system. If the JVM is for Linux, then the JVM knows how to interpret that bytecode to that particular operating system. So JVM and JRE are platform specific. As I already stated in my earlier video, it's platform specific, which makes your Java application to be called as a platform independent. Now, the one thing that you have to notice here is the same person.class is what is executed in two different platforms. One is your Windows, another one is Linux. So as a developer, I write once, but I can run it anywhere. It could be on Windows or it could be on Linux. That doesn't matter, right? So obviously, because we are working on top of the platform independent technology, right? So we are using a language which helps us to run it on anywhere. So I again stress out here, it's VORA, write once and run anywhere. So this is the main advantage of JRE. The two major important things that you have to recall when it comes to the JRE is platform specific. JRE contains JVM in it, and JRE performs many steps. But out of that, the two important steps that we need to look forward here is the class loader, which loads the dot class into it, and the class loader will hand over the loaded dot class to the bytecode verifier, who will check for the originality of the bytecode and also check through the standards of the bytecode. Once that process, the verification process is completed, it will hand over the bytecode to the JVM, and the JVM will further interpret it to the corresponding operating system. In the next video, we are going to see a small demo of how this bytecode can be interpreted by the human and what the JRE is going to do, what the bytecode verifier is going to do. that we are going to understand by a demo. Once that demo is done, then we will understand more in detail of the JVM. So thank you so much for your time. I'll catch up in the next video.